Welcome to another intermediate algebra video. In this video, we're going to look at complex numbers. Our two objectives that will deal with complex numbers. The first one is to write square roots of negative numbers in the form bi. So complex numbers come from radicals that have a negative underneath. We'll see that on the next slide. And then our other objective is to then add, subtract, multiply, and divide with complex numbers. Like with pretty much anything we learn in this course, we learn how to kind of initially deal with it, then add, subtract, multiply, divide, maybe solve problems that include this. We won't solve problems that have complex numbers, but we'll do all the manipulations with them. So the notes, a complex number is a number that involves, let's make sure that involves this I piece, this imaginary piece. Imaginary. And it comes from the square root of a negative number. So remember previously, if we saw something like the square root of -4, we would say, well, there's nothing we can square to get a -4, so we would say, no good, no solution. But the truth is, there's just no real solution. There is a complex or imaginary solution. So that negative, just think of it as a different piece. You've got a number that you deal with, you've got variables that you deal with. That negative is another thing you deal with under the radical. If there's a negative, it comes out of the radical as an I, meaning an imaginary piece. You don't get a real solution, you get an imaginary one. So a couple of things to note about this I. This is where it comes from, the square root of a negative number. And then one other important piece, if you take that I value and you square it, you get -1. And so that's how it's imaginary. Because if you go back to this type of problem, or even we can sort of take this one and solve it. If we tried to solve for I, well, we would take the square root of both sides. The square root of I squared would be I. And on the left, we would have -1. So you can see how the two are related. Okay, then we have complex numbers. So these are numbers that involve this imaginary piece, but they also have a real component. So a complex number has an imaginary and a real component, and a complex number should be written in this format, a plus bi. So the add, subtract, multiply is pretty simple with complex numbers, as long as you keep this second note in mind. And then for division, we'll have to use a complex conjugate, similar to when we rationalized in an earlier video. So this will be used for division, but we'll talk about that when we get there. All right, so let's look at some examples. The first one, we have the square root of -36. So we're going to look at this as two different pieces. Remember, using the product rule, we could separate this. There we go. We could separate this to be the square root of -1 times the square root of 36. The square root of 36 is 6, and the square root of -1 is I. Pull these two together, and we have 6i. Just like any letter, we typically put it after the coefficient piece or the number piece. So while it's okay if you wrote I6, 6i is the more standard way of writing it. So you could use the product rule to come up with this, or you can look at this problem and say, well, the negative will come out as an I, and then the square root of 36 is 6. So you have I times 6, again giving you 6i. And you don't even have to do it in these separate steps. You can do it all at once. I just want you to see that the negative is its own thing, and it has its own property of coming out as the imaginary, and then the number you deal with separately. Okay, the second problem, the square root of -5. Well, negative underneath the radical can come out as an I. We have I root 5. And then square root of 5, well, 5, you can't break down at all. You can say 1 and 5, but that doesn't help. So there's nothing we can do with 5. So this is it, I square root of 5. Okay, the next one. There's a negative on the outside. Remember, that was always okay. There was no problem there. And then the negative underneath the radical. This is where the problem was before, but now we know we can take that negative out as an I. So there's already a negative on the outside, and then the negative inside came out as an I. And then we want to take 20, break it down, and look for pairs. We have a pair of 2s, so a 2 comes out and a 5 is left inside. And then, as I mentioned, it's more common to see, it's standard to see the number written before a variable, before a letter. So this is what negative square root of negative 20 would simplify to. That negative on the outside remains, it's just carried along throughout the entire problem. The negative inside comes out as an I, and then the square root of 20 simplifies to 2 root 5. All right, and the last one, we can do a little bit of multiplication to begin with. Negative 3 times negative 5 gives us positive 15, and then there's nothing we can do to simplify that one. All right. So this is simplifying and getting something in the form bi. This is the first objective. The second objective is add, subtract, multiply, and divide complex numbers. So, an addition problem. This is typically how you'll see the problems presented. The reason they have parentheses is so that you can clearly see there is a first complex number and then a second complex number. This is a complex number and this is a complex number. And you're adding them together. But it's really no different than any sort of problem where you had whole numbers and x terms. You just look for like terms. The parentheses with addition don't really do anything. 2 plus 3i plus negative 3 plus 2i. And if you didn't write this plus here, that's okay. This 3 is negative. It already has a sign with it. And then just combine. The real pieces combine to be negative 1. And the imaginary pieces, plus 3i plus 2i, combine to be plus 5i. So we have negative 1 plus 5i. You might be wondering, what if I wrote my final solution as 5i minus 1? Typically that's not a problem. There's kind of a standard way of doing things, an order, but usually it's not a problem. When we're dealing with complex numbers, it is a problem. For it to be a complex number, the first thing should be the real piece, which means the piece that doesn't have the I, and the second piece should be the imaginary piece, the piece that has the I. So it should be written in this order, negative 1 plus 5i. Okay, the second one is a subtraction problem. Just like any problem where there's a minus and then a parentheses, it's ultimately going to be combining like terms, but first you have to distribute that negative. So we have the 5i that we started with. This is a complex number. It just doesn't have a real component. Minus 1 minus I. And combine like terms. We have two imaginary pieces. 5 minus I is 4i. And then a real piece that doesn't combine with anything but still exists. It's a minus 1. This was a plus 4i. And again, it should be written in this order. You should see the real piece first, and the imaginary piece second. All right, so there's add, there's subtract. Let's look at multiply. Multiply, again, it's one complex number multiplying by another complex number. But if I told you to multiply and the problem said 2 minus 5x times 4 plus x, what would you do? You'd have to go through the whole process of FOIL, and so that's exactly what you do here. So let's use some color. First, we'll take the 2 and multiply it by everything in that second parentheses. So we get 8 plus 2i. Then we take the negative 5i and distribute it to everything in the second parentheses, giving us negative 20i minus 5i squared. And then we clean up as usual. So typically the only thing we can do is combine those middle two terms. 2i minus 20i gives us minus 18i. But there's actually one more thing we can do. It's a new thing. We haven't seen doing this yet, but it's from the notes on the note page. This I squared in particular. Remember, I squared is equal to negative 1. So if we have an I squared appearing in our problem, we can substitute in a negative 1. This, we no longer need I squared. We want negative 1. Whoa, what color did I just pick? Good. All right, so we have 8 minus 18i minus 5 times, not I squared anymore, times negative 1. And then continue cleaning up. Now there's more we can do if we have a number here. 8 minus 18i plus 5, and then there's two whole numbers. We can combine those together. 8 plus 5 gives us 13 minus 18i. They should be in this order, the real piece and then the imaginary piece. And so this is multiplying complex numbers. It's not any different than dealing with variables. Just think of that imaginary piece as a variable, but a variable that needs to be written second. And that I squared equals negative 1. All right. The last problem is a division problem. And technically it's called dividing with with complex numbers, but it's very similar to rationalizing. The ultimate goal with division here is that we don't want the imaginary to be in the denominator. So, we dealt with this before when we were rationalizing a problem that had two terms in the denominator. Maybe you remember the strategy. If we had two terms, which we do here, 1 minus I, we used the conjugate, which was the exact same denominator with the opposite sign in the middle. If we started with minus, it was plus. If we started with plus, it was minus. And so we'll use the conjugate again, but here it's called a complex conjugate because it's with complex numbers. So our current denominator is 1 minus I. We are going to choose to multiply the top and bottom by the complex conjugate, which is 1 plus I. Remember, we make this decision, we choose this, for a specific outcome because we know what will happen in the denominator. In the denominator, the I should cancel out in some way, and so we'll see that happen here. So we want 1 plus I, 1 plus I. Okay, so let's work out each multiplication individually. Let's start with the numerator. In the numerator, we have 2 plus I times 1 plus I. So we have to FOIL just like we did for multiplication. We have 2 plus 2I plus I squared. Clean this up. 2 plus the middle two terms combine to be 3I. And this I squared becomes a negative 1. So plus negative 1 or just minus 1, however you want to write it. And then we can combine the numbers. 2 minus 1 is 1 plus 3I. So the numerator, after all is said and done, becomes 1 plus 3I. Then the denominator. In the denominator, we're multiplying the two quantities, 1 minus I and 1 plus I. These two are conjugates of each other and have a special relationship. You'll see what happens. 1 times 1, 1, plus I minus I squared. And you might be looking at it and thinking, well, the i's didn't go away, but let's keep going. Plus I minus I is gone. we have 1 minus I squared. But remember, I squared is equal to -1. So we have 1 minus -1. 1 minus negative becomes plus. So we get 2. 2 as the denominator. So we have 1 plus 3i all over 2. And because we're dividing, and ultimately when we divide one thing by another thing, we want just one thing in the end. So you should separate this to say 1 over 2 plus 3 over 2i, so that you can very clearly see the real piece and the imaginary piece. So again, we chose the complex conjugate as the thing that we multiply top and bottom. And the numerator, sure, works out and we get a complex number, that's fine. The denominator will always work out where you get just some specific number. The i's should go away in some way because you're choosing a complex conjugate where the middle two terms will cancel and the final term will always have an I squared, which can be replaced by -1. It might also have another number, but it will have an I squared. So this is very similar to rationalizing. It's called division, but the process ends up looking just like rationalizing. Okay. So let's do some practice. Okay. Go ahead and pause the video, go through these 3. The first one, simplify. The second, divide. Remember, the ultimate goal with division is to get rid of the I in the denominator. So we didn't see one explicitly like this, but we did in rationalizing, so you should be able to carry the idea through. And then a subtraction problem. Okay, let's go through them together. The first one, we have a negative on the outside. That's fine, it carries through. The negative on the inside comes out as an I, and then the 18 we can break down to 2 and 9, 9 to 3 and 3. We get a pair of 3s, so 3 comes out and a 2 stays inside. We'll just write this in the proper order. -3i square root of 2. Good. The second one is divide. Remember, the ultimate goal is to just not have the I, the complex piece, in the denominator anymore. So what can you multiply in? What can you choose to multiply in, top and bottom, so that the I will go away? Well, you have this nice feature that I squared is equal to 1. So if we multiply another I in, top and bottom, we'll have an I squared on the bottom, and it'll go away. Let's go through it this way, and then I'll show you one other thing. So straight across gives us 5i over 2i squared, which simplifies to 5i times over 2 times -1, 5i over -2. And this one doesn't have a real and imaginary piece, it's just the imaginary piece, so this is good. But you might be wondering, what if I chose 2i? What if I chose the entire denominator? That would also work out. If you chose 2i, on top you would get 10i. On the bottom you would get 4i squared. The 10 and the 4 can simplify to 5 over 2. The I squared in the denominator becomes -1. And then ultimately you get the same thing. So if you chose 2i, would also be fine. Okay, and the last one, subtraction. We have -5 minus 2i minus -8. Again, these are two complex numbers. With subtraction, we just distribute that negative. Minus negative becomes plus. Combine like terms, -5 plus 3, plus 8 gives us 3, minus 2i, and it should be in this order as the real and then imaginary piece, creating a complex number. Okay, so in this video we looked at simplifying and getting an I, and then all operations dealing with complex numbers: add, subtract, multiply, and divide, meaning ultimately the process of rationalizing. I'll see you soon for another video.